Alright, in chapter 14 we have a few different ideas. We have this idea of probability, and we have this idea of combinations and permutations, or the number of ways things can happen. So before we can hit on probability, we need to first start with the number of ways something can happen. So in 14.1, most of what the problems talk about is either this thing called the fundamental counting principle, which is when you have multiple things happening, multiple options, versus the permutations of an event happening, which talks about an order needed or an order that's necessary. So let's go ahead and talk about the fundamental counting principle. So again, this is used when there are multiple choices are given. So used when multiple choices are given. An example of this would be like if I'm picking between ties, shoes, and coats to wear, and I have multiple options of those each. So what the fundamental counting principle says is, let's take that idea of the number of choices. So think about the number of choices that you have, and spread those out. So say we had that coat example that I just said, ties, shoes, coats. Well, you're going to multiply them all together to figure out how many total options there are. So I'm going to take the number of option 1, so this is option 1. I'm going to multiply it by the number of options for 2, and I'm going to multiply that by the number of choices for option 3. So again, what am I doing with these? I'm multiplying each option by each other to get the total options. So an example, we're actually going to skip down this page for a second, is if we go to the woman going out for the evening. So I'm going all the way down to number 5. So a woman's going out for the evening. She will put on one of 6 dresses. So one of 6 dresses. There's 6 dresses option. 1 pair out of 8 pairs of shoes. And is going to go to one of 7 restaurants. So in this case, we have to figure out how many total options are there. Well, I can wear 6 dresses. I can times that by 8 different types of shoes, and I've got 7 different restaurants that I can visit, or that she can visit. So in the end, really it boils down to, what is 6 times 8 times 7 equal? Well, 6 times 8 times 7, that gives us 336 different ways that she can combine those. So like one way to think about this would be to make the list off to the side. But if I do one dress paired with all 8 restaurants, paired with all, or 8 shoes, all of the 7 restaurants, and to do that for all of them is exhausting. So again, multiplying them all is that that fundamental counting principle. Sometimes you may hear me say FCT. Alright, so then after this one, this is the one that you should try on your own. But let's go revisit some of these problems up here. So number 1, how many codes, 4-letter codes, can be formed using 4, D, Q, and X, or P, D, Q, and X, without repeating them? So basically, if I have a 4-letter code, that means I have 1, 2, 3, 4. Well, in this first slot, I can have one of these 4 letters. So I can have 4 options. But if I cannot repeat, so without repetition, that means I now only have 3 options left in the second slot. And again, I have 2 options left, and I have 1 option left. So the total amount of codes then is just found by multiplying those all together. So if I multiply these together, I get a total of 24, sorry. 24 codes if I'm not repeating. So kind of same thing here. How many 6-digit numbers can be formed using all digits 0 through 4 without repetition? Well, 0 through 4 is misleading because it's 0, 1, 2, 3, 4. So there's actually 5 options. Alright, without repetition, again, make your slots 1, 2, 3, 4, 5. You should probably realize it's just 5 times 4 times 3 times 2 times 1, which gives us 120 options. Alright? So now what I want you guys to think about is, well, we've had a term for this. We had 4 factorial. So remember that factorial means, or a number to the factorial means that number, or let's go with more like n factorial. That's really n times n minus 1 times n minus 2, and you're going to keep going. So that's that factorial idea. Well, notice that this problem was just 5 factorial. So that's an easier way to get there. Alright? So I want you to go ahead and do 3 and 4. Again, these are kind of spitting images of the last 2. So let's see if you can try those out. Now let's move on to permutations. Alright, so that was the first type of way that we can come up with things. So the next way to come up with things is called a permutation. Now, I'm going to call this part 1 of permutations. So permutations are ordered, again, ordered being the key word, arrangements of all terms in a set. So a permutation, what that looks like is, you've seen combinations before, but we won't get to those till 14.2. It looks like NPR. So you bet you can find that in your calculator. Well, sometimes your book is going to actually in this case, we're going to do NPN, because we're going to do all terms for these. So what your book shows this as sometimes is P of NN. So this is only used if I'm choosing all the ways something can happen. Well, that's like the first page where we had the bicycles and we had the codes. That just equals n factorial. So an example of n factorial, again, from the first page, 3 factorial is 3 times 2 times 1, which is 6. If you need another example of what that factorial means. It's not just excited math or something like that. Alright, so number 7 asks you how many ways can 7 people line up. So that's kind of like, again, like the codes. If I want 7 people to line up in a row, it depends on where they go. So I'm doing 7, and I'm picking 7 to line up. So really, I'm just taking 7 factorial. Alright, well, 7 factorial, what is that? It's technically 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, in your calculator, you can figure this out. If you go in your calculator to math, arrow over to probability, PRB, NPR is there. Now in the older calculator, you need to type in what you want first. So I want 7, I want N7R is 7. That's what I was talking about. This is technically R, but for these examples, so for this whole page, N equals R. So 7P7, again, is 5040. And if I went over here, I could also just do factorial. I could do 7 factorial. Oops, I need to put 7 in there. And again, same thing. So 5,040 ways. Right? So, and this one is pretty much the same as the problem in the front, but that one's where you're going to try that. Alright, 8. How many permutations are there? The letters of the set. So permutations tells me that I want the number of ways that that set can happen. So I have how many total? I have 1, 2, 3, 4, 5, 6. 6 things. So I have 6. I am picking 6. So I have 6 factorial, which again, 6 factorial, I can just go on my calculator, 6 math, probability, factorial, or 6p6, 720 ways. Alright, and again, number 10 will be your U-try problem. Alright, so moving on here. The owner of a business hires 8 secretaries, 1 for each of the 8 department managers. How many different assignments are there? So 8 secretaries, 8 departments. We're doing 8p8. Alright, so 8p8 is 8 factorial. And if we do that, we get 40320 different ways. Now you don't really have to put the number of ways. Alright, fruit stand selling apples, again, how many different ways? Fairly self-explanatory, you can do that one on your own. Alright, so now you notice we get to the part where it says permutations again. Well, what does this mean? Just means that we're going to go ahead and talk about permutations when we're not picking everything in the row. So, basically, permutations number 2 is order arrangements. So, sorry, let me get a different pen here. This is part 2. Ordered arrangements of some of the items in a set. Alright, so the way this goes is now this is the true NPR, where NPR stands for n factorial, but we need to divide out the ones that repeat. So n factorial on top stands for number of ways we arrange n items. And on the bottom, n minus r is dividing out the unselected terms. So divide out unselected terms. So anything we don't want, we have to take out. Again, n is going to be your total. R is the number you select. Again, some ways that you might see this in your book. So NPR is equivalent to P with N choosing P, or PN with R. Those are both ways you might see it written. Alright, so let's talk about a few of these, and then we will be done and ready to go and finish out this section. Alright, so 13. How many ways can the letters in the set, so 1, 2, 3, 4, 5, be arranged to form codes of 4 letters? So 5 is N, and I'm choosing 4-letter code, so that's R. In codes, they matter. They have an ordered to them. Again, this key word here, ordered. So n, 5, pick 4-letter codes equals 5 factorial over 5 minus 4 factorial. Well, what is this really? It's 5 factorial over, well, 1 factorial. Well, 1 factorial doesn't really matter. It's kind of gone. So this is really just 5 factorial. And we've done 5 factorial before. Technically, this is just 120 codes. Alright, so that's the first one. Notice here it said, what about 3-letter codes? So 3-letter codes, we're doing 5. We're picking, instead, 3. So that changes the game a little bit. 5 factorial over 5 minus 3 factorial. So that's 5 factorial over 2 factorial. Well, you can do this in your calculator, or you can just multiply it out on your own. Just be careful about how you enter it. So 5 factorial, I'm going to divide it by 2 factorial. Really, I'm just dividing it by 2. But I'm just going to put a factorial in there because you should get used to doing that. Alright, I get 60 different ways, so 60 codes. 60 codes of 3 letters, and I've got 120 codes of 4 letters. So 4-letter and 3-letter codes. Alright, so 14, again, that will be yours to try. Let's go ahead and talk about number 15. So how many ways can 4 people, so that sounds like a total, be assigned, assigned being your keyword for permutation, to a 6-person or 6 one-person offices? So that's 6 offices. Really, that's your total. 4 people is what we're choosing. So we have 6 offices, pick 4 people to go in them. That's 6 factorial over 6 minus 4 factorial. So we got 6 factorial over 2 factorial, and dividing that out on your calculator, or let me show you this one by hand. 6 times 5 times 4 times 3 times 2 times 1, all over 2 times 1. Well, notice the 2's cancel, the 1's cancel. So then you just have to do the rest there. Alright, so that ends up being 360 ways that you can arrange those. And of course, 16, that's going to be yours to try, kind of mimicking here. And then I want you to see if you can do this one. This is the challenge problem. So you try the challenge problem. 7-digit phone number, sign no digits used more than once, and the first digit is not 0. So what I want you to think about is 1, 2, 3, 4, 5, 6, 7. That's my hint. Start there and figure it out from there. Alright, that's all the notes I have for you for this. You should be set now to go ahead and do the 14.1 bookwork. And we can ask any questions in class.